More graphing linear inequalities. Today we're going to graph inequalities in standard form. Okay, but first, let's review what we already know about graphing inequalities. Okay, when we graphed inequalities in slope-intercept form, you just needed to remember two things. Is the line going to be dashed or solid? And we needed to remember whether or not we shaded above or below the line. So let's try an example. Suppose we wanted, this is the old example, suppose we wanted to graph y is less than 3x minus 4. Okay, well, we would start at negative 4 on our y-axis. We would do rise over run to get a couple more points, so up 3, 1 to the right, up 3, 1 to the right. But before we connect our line, we need to decide, is our line going to be dashed or solid? Well, it's a less than sign instead of a less than or equal to sign, so the line will be dashed. The next thing we need to worry about is where to shade our graph. So it's a less than sign, so we know we need to shade below our line. So we're going to shade everything below our line. This gives us all possible x and y coordinates that have values that would work in this inequality. If I wanted to try a sample, maybe I want to try the point 4, 1. Well, 3 times 4, because that's our x-coordinate, is 12. 12 minus 4 is 8, and 1 is less than 8. So I know that point works. Okay, so what about standard form? How do we graph that? Well, let's start with the equation 2x minus 5y equals 15. Well, if we wanted to solve that equation, we can get it into slope-intercept form. And how do we do that? We get the y alone. We solve for y. Well, similarly, if we want to solve an inequality that's in standard form, we need to get it into slope-intercept form. We need to get the y alone. Okay, so let's try an example. Let's rewrite each inequality and then graph it. Okay, so suppose this isn't in standard form, but suppose we have the inequality negative 5y is greater than 2x plus 15. And I want to graph that and show all possible solutions. Well, I don't have y by itself yet, so I need to get rid of that negative 5, and to do that, we divide each term by negative 5. Well, the negative 5's cancel, and the negative 2 over negative 5 is positive 2 over 5, and 15 divided by negative 5 is negative 3. So we have y is less than 2/5 x minus 3. Why did it switch to a less than? You need to remember, whenever you multiply or divide by a negative, the inequality sign switches directions. Okay, so now we're going to plot the line. We're going to plot our y-intercept at negative 3. We're going to use our slope up to 5 to the right. Okay, we ran out of room, so for my bonus point, I'm going to go down 2 and 5 to the left. Okay, dashed or solid? Well, it's just a less than sign, so it's going to be a dashed line. And then I need to decide which way to shade. Well, it is less than, so I'm going to shade below my line. Okay, so I shade below. This is the solution to our inequality. Okay, let's try another example. This time we're trying to graph negative 6x plus 3y is less than or equal to 12. Okay, well, again, we're trying to solve for y, so we'll add 6x to both sides of the inequality sign. 3y is less than or equal to 6x plus 12. We'll divide each term by 3, and we're left with y is less than or equal to 2x plus 4. Okay, so to graph that, we're going to start at 4 on our y-axis. We'll use our slope to get 2 more points, up to 1 to the right, down to 1 to the left. This time, I connected them with a solid line because it was less than or equal to. Okay, now we just have to decide, are we going to be going above or below the line to shade? Well, it's a less than sign, so we're going to shade below the line. So all of these points that are being shaded in now are part of our solution set. Okay, let's try one more. Our last one, I promise. Okay, so this time we have 2x minus 4y is less than negative 16. We want to convert to slope-intercept form, so we're going to start by subtracting 2x from both sides and then dividing each term by a negative 4. The thing that we need to remember again is that since we're dividing by a negative number, the inequality sign changes directions. So we're left with y is greater than positive 1/2, right? Because negative 2 divided by a negative 4 is a positive 1/2, x plus 4. Again, it's a positive because a negative and a negative gives us a positive. Okay, we're going to graph our line. We're going to start at 4 on our y-axis, up 1, 2 to the right, up 1, 2 to the right. Okay, when we connect and add our arrows, it's a greater than sign, so it's going to be a dashed line. And this time, we need to shade above the line because it's a greater than sign. So I'm going to shade in everything above the line to give us our solution set. Okay. Okay, now it's your turn. You're going to complete problems 1 through 4 on the Standard Form Inequalities Practice 1 worksheet. You can find it in Schoology. Good luck!